How to avoid circular imports in Python. I know the issue of circular imports in Python has come up many times before, and I have read these discussions. The comment that is made repeatedly in these discussions is that a circular import is a sign of a bad design and the code should be reorganized to avoid the circular import. Could someone tell me how to avoid a circular import in this situation? I have two classes and I want each class to have a constructor method which takes an instance of the other class and returns an instance of the class. More specifically, one class is mutable and one is immutable. The immutable class is needed for hashing, comparing, and so on. The mutable class is needed to do things too. This is similar to sets and frozen sets, or to lists and tuples. I could put both class definitions in the same module. Are there any other suggestions? A toy example would be class A, which has an attribute which is a list, and class B, which has an attribute which is a tuple. Then class A has a method which takes an instance of class B and returns an instance of class A by converting the tuple to a list, and similarly class B has a method which takes an instance of class A and returns an instance of class B by converting the list to a tuple.
Only import the module, don't import from the module. Consider a.py, nb.py, this works perfectly fine. Consider the following example Python package where a .py and b.py depend on each other. Types of circular import problems. Circular import dependencies typically fall into two categories depending on what you're trying to import and where you're using it inside each module, and whether you're using Python 2 or 3. 1. Errors importing modules with circular imports. In some cases, just importing a module with a circular import dependency can result in errors even if you're not referencing anything from the imported module. There are several standard ways to import a module in Python. Unfortunately, only the first and fourth options actually work when you have circular dependencies, the rest all raise import error or attribute error. In general, you shouldn't be using the fourth syntax, since it only works in Python 2 and runs the risk of clashing with other third-party modules. So really, only the first syntax is guaranteed to work. Edit: the import error and attribute error issues only occur in Python 2. In Python 3 the import machinery has been rewritten and all of these import statements, with the exception of 4, will work, even with circular dependencies. While the solutions in this section may help refactoring Python 3 code, they are mainly intended for people using Python 2. Absolute import. Just use the first import syntax above. The downside to this method is that the import names can get super long for large packages. Inner.py, inb.py, defer import until later. I've seen this method used in lots of packages, but it still feels hacky to me, and I dislike that I can't look at the top of a module and see all its dependencies. I have to go searching through all the functions as well. Inner.py, inb.py. Put all imports in a central module. This also works, but has the same problem as the first method, where all the package and submodule calls get super long. It also has two major flaws. It forces all the submodules to be imported, even if you're only using one or two, and you still can't look at any of the submodules and quickly see their dependencies at the top. You have to go sifting through functions. init_dot_py inner.py inb.py 2. Errors using imported objects with circular dependencies. Now, while you may be able to import a module with a circular import dependency, you won't be able to import any objects defined in the module or actually be able to reference that imported module anywhere in the top level of the module where you're importing it. You can, however, use the imported module inside functions and code blocks that don't get run on import. For example, this will work. package/a.py package/b.py But this won't work. package/a.py package/b.py You'll get an exception. Attribute error, module package has no attribute A. Generally, in most valid cases of circular dependencies, it's possible to refactor or reorganize the code to prevent these errors and move module references inside a code block.
We do a combination of absolute imports and functions for better reading and shorter access strings. Advantage: shorter access strings compared to pure absolute imports. Disadvantage: a bit more overhead due to extra function call. main/sub/a.py main/sub/b.py
If you want to see more, please consider subscribing.